Okay, so this time we're going to do an exponential growth question. And when we're looking at exponential growth, there's a few things that we can be talking about. You can be talking about populations or money or whatever it is. It's always the same formula, though. It's always going to be the same idea. So again, you're going to have ones probably written in all different word problems, but they're going to be using these words in the word problems. And so what I did was I just made a table of values. We're not going to go through a word problem particularly. I can do that if you ask me to in some other video. But what we're going to do is we're just going to, as though we read the word problem and we wrote down the information that we had here so that you can see how to solve all these different kinds of problems. Okay? So there's always an initial investment, or it would be the initial population or the starting population, or any word that means initial, right? There's going to be a rate. Usually it's an annual rate. Every once in a while they'll say it's like for a minute or something. They'll say how much it changes per minute, like if it's bacteria or something. They'll have, maybe they'll give you some information about, this one says time to double, but maybe it says how much you'll have in so many years, or they'll say, how long does it take to triple, or how long does it take to be cut in half? And then it will tell you, usually the question that they're actually asking you, how much will it be after so many years? Okay, so we'll just do the first one here, and we'll do these ones probably separately so you can watch 1 or 2 or 3 or 4 or as many as you like, but we'll do them one at a time. So the formula that we're going to use is our PERT formula. It doesn't really matter what letter you use for these ones. I use P for principal. You can use whatever letters you want. E is a constant, of course, so we have to use E. R is the rate and T is time, so we usually use R and T, but the other two letters, it really doesn't matter what you're going to call them. You can call them I for initial investment, whatever you like. It doesn't matter. Okay? So in this first one, what's the information that's given? Well, the information that's given is our initial investment, which is, of course, this one. So our initial investment is going to be $1,000. And E is a constant. He stays the same. My rate is given. So R is given. So what am I going to put there? Well, not 12, but 0.12, right? Because that is our rate in decimal form. I'm just going to put T for time, and then we don't know this one either, okay? Now, there's a couple things they want us to do. They want us to find out how long it will take to double and how much we'll have after 10 years. Now, this one is probably the more common question, so we'll do that one first. So how much will we have after 10 years? All I have to do is put a 10 in here. So we're going to get B is equal to 1,000 E to the 0.12 times 10. And basically, this is just punching it into my calculator because I don't know those numbers, but my calculator does. So let's take a look. So I'm going to type in 1,000. Then I'm going to hit the second button and this little ln where there's an e to the x on top, and you see how it made a space for my exponent already. And I'm going to type in 0.12 times 10, or you could actually even use the parentheses just like I have here if you like that too. But I usually just use the times one and not worry about all the parentheses. And now I'm going to hit enter. So I'm claiming that after 10 years, I'm going to have 3,320, and I'll make it 0.12 since it's money. We'll round to 2 decimal places. Okay, usually I would say round to at least, right out to at least 4 decimal places. And so now we can see that that's the number in 10 years. Let's look at this one that's time to double. Okay, so this one is one where it kind of doesn't matter what we pick for the original. If you want to pick 1,000, because that's what they told us, we can do that. So let's put in the 1,000. And we'll do some later in the other videos where I don't use 1,000. I'll just use some random number, but we'll talk about it when we get to there. I'm going to use the rate. Time is something I don't know, okay? So that's what I'm looking for, time. That means I have to be able to fill this in with something because I can only have one variable in here if I'm hoping to solve it. So let's think about this. If I want to know how long it takes to double my initial investment, then that means that I want this side to be 2,000 because that's double my initial investment. So to solve this one, I'm just going to divide both sides by 1,000. And of course, What do I have over here? A 2. And it doesn't matter what I had picked for my original and my double, this is always going to reduce to a 2. If they had said it started with 1 and you want to have $2 at the end, if they said start with $3 million and you want $6 million at the end, if it's always going to be twice as big, then after the first step, you're always going to end up with a 2 here if you're looking for the time to double. Okay, so that's what I meant by it doesn't matter what the original amount is. Okay, now remember that ln e is the same thing as log base e to the e, and we all know that both of these are 1 because it says what this says, what do I have to raise e to get e? And so that's always a 1. Okay, so from here, what am I going to do? I'm going to log both sides, but I'm going to use the natural log because I'm using the natural base, which is e. I'm going to bring my exponent down here because that's my log rule, says that I'm allowed to do that. And everybody knows now that this thing simplifies to a 1. So when I multiply by a 1, that's, the same as the original. I don't have to do anything. So this is like 0.12t times 1. So it's just this. So how am I going to figure out what t is? Well, t is going to be ln 2 divided by 0.12, and that's my time. Now again, if I were using this in the equation later, I probably wouldn't even change what it is. I would just leave it like that and work with it that way. But since this is the final thing, if you told me that was the time, I'd probably be pretty mad at you because that doesn't help me understand how long it's going to be. So I'm just going to type that number into my calculator. And this says 5.7762 years. So this one, again, since it's not money, I'm going to use at least 4 decimal places. Okay.